Welcome to another edition of Mr. Runyan's Screencast-O-Matic 2017 edition number 1. Hello, class. How are you today? Okay, application problem, just a reminder. So you should have already been instructed to work on the problem. Maybe you have the answer and now you're watching it. Maybe you're stuck and now you're watching it. If you don't have an answer and the time's still going, why are you watching it? Think about it. Okay, hopefully you got one of those. So if you're not done, pause it. If you are done, watch. And if you're stuck, watch. Here we go. Hannah and her friend are training to run in a 2-mile race. On Monday, Hannah ran a half-mile. On Tuesday, she ran 1/5 mile farther than she ran on Monday. How far did Hannah run on Tuesday? This is easy. Let's look at it. Okay, well, read, write, draw, right? So what do we have? Well, I see we have Hannah. They're running a 2-mile race. On Monday, Hannah ran a half-mile. On Tuesday, she ran a 1/5 mile. Farther, remember that please, than she ran on Monday. How far did Hannah run on Tuesday? So let's see. So on Monday, we know she ran a half-mile. That's it, right? You could draw that. You could say, there you go. So here's your half-mile. Correct? So that on Tuesday, it said she ran 1/5 mile farther. You have to read the directions. Just read. Read. She ran 1/5 farther than she ran on Monday. Oh, so if she ran farther than on Monday, she at least ran a half a mile, right? And she only ran 1 farther. So now, how do I solve this part? You have to add. It's easy. So now we start thinking about adding it. So now we have 1/2, add 1/5. Mr. Runyan once told me that I can't add these denominators if they're not the same, and 2 and 5 are different. So I got to make them the same. And how do we do that, class? Well, we take the big number, right? That's how I do it. Take the big number. It's 5. Add it. Multiple times. Just one time, though. We're going to find multiples. 5 plus 5 is 10, right? Can 2 go into 10? Yes, it can. How many times does 5 go into 10? Well, we only added it once, so 5 plus 5 is 10. And then what you do on the bottom, you do on the top. Come back to this side. How did you make 2 times what equals 10? 2 times 5. And again, what you do on the bottom, you do on the top. Thank you. Okay, well, then you end up with 5/10. Add 2/10. Well, easy peasy lemon squeezy, little ladies. We got equal denominators, 10 plus 10, right? Don't we add that, 10 plus 10? No, because that's the whole. We just add the numerator. 5 add 2 is 7. And it stays a 10 because the 10 describes the whole, a fraction of the whole. So the answer would be 7 cents. Time lapse. Lost you there, didn't I? Okay, now let's look at the next problem. So B, it says if her friend ran 3/4 mile on Tuesday, how many miles did the girls run in all? Well, that's as easy as changing your color first. Sometimes it's easier said than done. Okay, well, it just wants an all, so we just have to add 3/4, add 7/10. Okay, so now we think about it, okay. Take my big number, right? That's the easy thing. Grab the big number. Okay, you could just multiply 4 times 10, 10 times 4. it'd be easy, but you're going to have this really, really big number. Okay, so if you take that big number, you find the first multiple. The first multiple of 10 is 20. Can 4 go into 20? Yes. Okay, so how many times does 10 go into 20? Well, actually, let's do that in the color. Let's do beautiful color of green. I'd use red, but red and purple, we don't mix them. And what you do on the bottom, you do on the top. Oh, I'm gonna be off my screen. Yep. And times 5. Okay, so 5 times 3 is 15. 5 times 4 is 20. And you're gonna add 14. I can't do math over there, obviously. Nobody said anything. Nobody said that I was wrong. It wasn't 1. You can talk to me through a computer screen, can't you? 14 20ths. Right? Add 15 20ths. Well, you get 29 ths. Okay? Are we done with that? No, because it's called an improper fraction. Improper fraction means it doesn't look right. You need to run your don't look right, and it's improper. Yeah, that's what it's called. It doesn't look right. We got to make it look right, and we're going to turn it into a proper fraction. And a mixed number, which, same thing. Okay, so you just ask yourself, well, or can you take 20 out of 29? Yes. How many times? Well, you take 1. What's left? Well, 29 minus 20 is 9, and you're left with 20. Okay, and then you got to ask yourself, can I simplify? Can I make this smaller? Okay, 20 is an even number, so 2 goes into it. 5, 4, 1. Okay, what about 9? 3, 1. So you can't simplify. So we are done. There's your answer. 1 and 9 20ths. Now let's check. Here, zoom in. 1 and 9 20ths. Perfecto. Primo. Let's move on. Okay, we're going to skip this one. So let's look at this problem. So now we have a half add 2/3. Pretty simple, right? Yeah, this is ridiculously easy. So again, so a half add 2/3. I'll allow you to do the box method if you want. So if you had a half, and then you're going to add, remember you do it separately, and you're going to add 2/3. Well, we do that by combining them. And the way it works is essentially all you're doing is multiplying 2 times 3. You're finding 2/3 and a half. So like that, okay? You're finding the thirds. Okay, so we're doing it this way. And you split that in half. Okay, now you got 6. Oh, 6. 2 times 3, 6. Same thing, right? So now we add it, so all you got to do is add it. 1, 2, 3, 4, 5, 6, 7. So I'd have 7, 6. Okay, 6. 6's can you get out of 7? 1. There's 1 left. There's 1 and 1 6. Easy. Next one. Okay, I'd like you to pause, and I'd like you to do this one on your phone. Go. Did you pause? Good. So you're done. You're ready? Okay, let's look at it. So we have 5/9 add 5/6. So let's look at our denominators first. They are not similar. You could do the box method. So if you did that, bravo, way to go. But let's look at doing the common denominators. So 9 and 6. Again, take the 9, right? Multiples. 9 plus 9 is 18. Can 6 go into 18? Well, let's count. 6, 12, 18. Yeah, sweet. Okay, so I'm going to have 5/9 add 5/6. I'll do it in a different color just so you can see my work. Oh, red and purple. We don't want to mix. yucky birds. Okay, so how do you get to 18 from 6? You multiply it 3, multiplication, repeated addition, 6, 12, 18, 3 times. Okay, and what you do on the bottom, you do on the top. And we know this was twice, and what you do on the bottom, you do on the top. Okay, well then you can rewrite it, and you end up with 10 18ths, add 8 18ths. Well, if you add it all together, it looks like you're going to get this fraction called 18 18ths. 18ths. It's Italian for 18, which is English for 1. Because remember, a division, dang it, a fraction is nothing more than a, tell me for 50 bucks. Let's move on. Time lapse. Okay, problem number 4. So now we have 3 add-ins, which means basically you just have 3 add-ins, 3 problems we're adding. So we have 2/3, add 1/4, add 1/2. Does this affect the approach that we're going to take to solve it? Does it? I don't think it does. You can still take the big number, which is 4, right? Can 2 go into 4? Yes. Can 3 go into 4? No. Take the 4, add it. Multiples. 4 plus 4 is 8. Can 2 go into 8? Yes. Can 3 go into 8? No. Do another multiple. Okay. 8 plus 4 is 12. Can 2 go into 12? Yes. Can 3 go into 12? Yes. Common denominator. And that would be 12. Okay. There's a lot of different ways to do that. You could also just do the ones you know first, right? You could add a 1/4 at a half, knowing that a half is nothing more than 2/4, right? And then you're left with 3/4. Well, what's 3/4? Add 2/3. Okay, well, you have to find a common denominator again, so you're kind of going in a big circle in how you're solving the problem. So let's do it the first way that we looked at. Okay, so we started with 4, 8, we went to 12, we found out that they all work. So I'm going to pause it. Whoa, that was crazy. Time lapse. Okay, I paused it. I wrote the problem. Common denominator. How does 2 get to 12? Well, you multiply it by 6. What you do on the bottom, you do on the top. How's 4 get to 12? Well, you multiply it by 3. And what you do on the bottom, you do on the top. How does 3 get to 12? The same as 4. Well, kind of. Similar to 4, because it is 4. But not the same, because it's not 3. But it is 3. Okay, now we can rewrite it again. Unpause. Okay, so now what I've done is I just went ahead and solved all the multiplication and common denominators and common numerators that aren't common. Who cares? Anyways, okay, and I put it down here. So we have 8/12, add 3/12, add 6/12. All I need to do is add it across. 8 add 3 is 11. 11 add 6 is 17. You'd have 17/12. Okay, well, we can decompose that, right? Because 12 goes into 17 one time, right? And there's 5/12 left. So the answer would be 1 and 5/12. If I can do that right. There we go, kind of. So we have 5/12. Again, 5 can't go into 12. It's simplified. It's as easy and good as it's going to get. Okay, so we are on our problems. So at this time, make sure you at least have your book out. We're going to work on the problems together and solve it and pause and play and get them done. Ready? Let's go. Let's do this. Okay. Let's see what you can do first. Let's do A and B on your own. I'll do the work, and then I'll unpause it. So at this time, pause it and solve A and B. Go. Okay, hopefully you're done. So the answers that I got here were 25/20. and 1 3/8. I got that because I found out my common denominator for A was 28. I did 7, 14, 21, 28. 4 doesn't go into any of those until I got to 28, which just happened to be 4 times 7. And then do all the work and you get 25 28ths. Can't simplify it. There's my answer. Okay, so same thing here. I noticed 4 went into 8, so I didn't have to do much on this side. Multiplied each by 2, so I didn't really show a lot of work because I thought it was pretty easy. And then I got 11 eighths, and 11 eighths is 1 3/8. 8 goes in 11 one time. There's 3 left over, so it's 1 3/8. Okay, so let's go ahead and do C, D, E, and F, and I'm just going to put the answers up here instead of doing work. Go. It means pause it. Okay, good job. Go. Okay, so now you should be done with C, D, E, and F. C, the answer would be 45/56. D, the answer is 1 1/63. E, 13/15. And F, 1 7/12. Cough in the elbow, see that? Okay, we have G and H. Pause it and I'll put the answer. Go. Okay, the answer that I got for G was 25/33, and H was 1 17/20. Now remember, these are simplified down to as small as it can possibly go. All of these are. So let's look at our first word problem. So Whitney says that to add fractions with different denominators, you always have to multiply the denominators to find the common unit. For example, 1/4 plus 1/6 equals 6 24ths plus 4 24ths. Show Whitney how she could have chosen a denominator smaller than 24 and solve the problem. Pause and go. Okay, so hopefully you have an answer, or maybe you're stuck. So we use the Mr. Runyan method. We use the big number first. We're going to find that, there we go, in the middle. Okay, then we're going to find that common multiple. So we're going to, well, denominator, but multiples, kind of. So 6 plus 6 is 12. Can 4 go into 12? Yes, so then we have our answer. So 6 times what? 6 times 2. What you do on the bottom, you do on the top. Same over here, right? 4 times 3 equals 12. So then you end up with 3 twelfths. Add 2 twelfths, which is 5 twelfths. Right. Tis be the answer, matey. Excellent. Okay, and that's the easiest way. Take the big number, add it until you find a common factor, multiple, whatever you want to say. Multiple. Number 3. Jackie bought 3/4 of a gallon of iced tea to the party. That's my kind of guy. Or gal. Jackie could be a girl. Bill brought 7/8 of a gallon of iced tea to the same party. How much iced tea did Bill bring to the party? That's easy, right? You're going to add 3/4, add 7. So lean on note 2 that we just did and try to solve this without multiplying the denominators. Go. Okay, so you should be done. Well, right off the bat, I know 4 goes into 8. How many times? Twice, right? And what you do on the bottom, you do on the top. So you end up with 6, 8, add 7/8 equals 13. Whoa, whoa, I'm moving, whoa. 13/8, right? So now we're going to go ahead and simplify it. So 8 goes into 13 one time. There's 5 left. There's denominator stays the same. All right. So Madame Curie made some radium in her lab. Wouldn't suggest it. She used 2/5 kilogram of the radium in an experiment and had 1 1/4 kilogram left. How much radium did she have at first extension? If she performed these, no, let's not do that right now. Okay. So if she used 2/5 and had 1 1/4 left, so something subtract 2/5 equals 1 1/4. Okay. Well, how do we get this? Let's just say it's x. Okay. Well, remember, we want to get it by itself. And how do we get this by itself? We want to get rid of this. Well, we're going to add 2/5, right? And what you do on this side, you got to do on this side. So we're going to add 2, right? And so we'll basically are saying that you are learning algebra and you don't even know it. Oops. There we go. So basically we're saying equal, which is our variable. X equals 1 1/4, add 2/5. Okay? It's easy. So now all we have to do is add it, right? So 4/5, well, common denominator, right, would probably be 10, no. 15, no. 20, yes. Change my color. Let's be green. Okay, well, it's 5 times 4, and it's 5, right? You do them on top, and you end up with 1 5/20. Add 8/20. Yep, there we go. Which ends up being 1 13/20. I would totally drink it. So make sure that you, if you're finished, do the problem at the end of the video so that you can get your credit and your points. Thanks for listening.